Hello everyone, hope you're all doing well and welcome back to our channel Chemistry with RK. Yes, I know it's been so long I did not share any video in my YouTube channel. So it seems like so many of you are eager and have been getting the requests and commenting in the for the past videos like so why you stopped uploading the videos. We are eagerly waiting. So I've been getting such comments for my past videos. So, firstly, thank you so much for that. Yes, I'm going to share good news to all. So, the reason behind not posting any video for so long is I'm blessed with a baby boy. So, I just wanted to spend some time with him since he's so small. And yeah, I'm promising everyone I'll ensure that I'll be posting videos regularly from now. I'm so sorry for the big break. Before going to our video, I would like to request if you're new to the channel, please don't forget to click on the subscribe button and then also on the bell icon to get the regular updates. So without any delay, we will start our today's lecture. So I'm going to talk about aldol condensation in this video. Okay, so like in JEE aspect or NEET aspect, this particular reaction is very important. So if you just look at the previous exams, different competitive exams, every paper will have a question, at least one question from this particular reaction actually. So this aldol condensation has a huge importance in the competitive exams. So before we move into aldol condensation, we must know the meanings for alpha carbons and also alpha hydrogen. So let us see what exactly these terms are. Now, the carbon atom attached to the functional group carbon. So this carbon I'm talking about, this is our carbon which is directly attached to the functional group carbon. So this, if you look at, this is our aldehyde functional group and this is the aldehyde carbon and now this is our alpha carbon. Hope it is clear. And now the hydrogens to this alpha carbon are called as alpha hydrogens. Clear? So let us take one more example. You take acetaldehyde, yes. And now, if I'm not wrong, this is our functional group carbon. And now the directly attached carbon is this. And now you can see the three alpha hydrogens are present to that alpha carbon. So hence acetaldehyde contains three alpha hydrogens. Okay, let us take one more example to make it much more clear. That is acetone. Let us go for acetone. Acetone contains two methyl groups attached to the carbonyl group. So now this is our carbonyl carbon, which is our functional group carbon, and these are the directly attached carbons, which is nothing but our alpha carbons. And you can see each of this alpha carbon containing three hydrogens, which means acetone contains 6 alpha hydrogens, if I'm not wrong. Hope it is clear. You take other example. Come on, let us go for propanol. Propanol, yes. Come on, try to answer this. So this is our functional group. This is the directly attached carbon, alpha carbon, and the two alpha hydrogens you can see here. I hope it is clear, right? Chalo, let us go for formaldehyde. Formaldehyde. Yeah, you try to tell me how many alpha hydrogens you can see here. So this is a functional group and now there is no alpha carbon at all. So when we don't have any alpha carbon, then we obviously don't have alpha hydrogen. So please don't misunderstand. This is not our alpha hydrogen. This is not our alpha hydrogen. The hydrogen must attach it to alpha carbon to call it as alpha hydrogen. So formaldehyde does not contain any alpha hydrogen. Hope it is clear. So let us go for our beautiful cyclohexanone. Cyclohexanone. Yes, this is our carbonyl group. This is our functional group carbon, and these are the directly attached carbons, alpha carbons. And if I'm not wrong, these are our alpha hydrogens, right? So these are the alpha hydrogens. So totally we can see 4 alpha hydrogens in cyclohexanone. Without any doubt, I hope you can answer this. Clear? Okay. You take another example, that is 2-methyl cyclohexanone. Come on, you try to answer this now. Come on. So this is a functional group and this is the functional group carbon. These are the directly attached carbons. And here you can see 2 hydrogens attached, but here you can see only 1 hydrogen. Total overall you can see 3 alpha hydrogens. Hope it is clear, right? Now, so why exactly you are focusing more on this alpha hydrogens? So, to understand that, I would like to take one beautiful explanation here. So, this is our skeleton structure of the carbonyl group, right? Now, you know that among these two bonded atoms, oxygen is electronegative and the electron density is more concentrated towards the oxygen itself, creating a partial negative on itself and then giving a partial positive on the carbon. Now we know that carbon with partial positive or maybe positive charge is generally called as carbocation. Carbocation. So generally carbocations are less stable. What is the reason for that? So this is due to their electron deficiency. So when we can expect a positive charge on any atom? When it has some kind of deficiency. So here you can see carbon with a positive charge, which means the carbon is now electron deficient. Electron deficient species are generally considered as electrophiles. So which means in this carbonyl group, the carbon is now behaving as a electrophile. So the carbon is now, we can call it as electrophilic carbon. So towards the electrophile, which species will be interested to come actually? The electron efficient one, which is our nucleophile. So towards the electron efficient species will try to come, which is a nucleophile. So now let us just compare these two situations in aldehydes and ketones. So we have aldehyde RCHO and then ketone RC double bond OR. So we can see the same kind of situation here. There is nothing different takes place here. So obviously oxygen gets a partial negative and the carbon gets a partial positive in both the cases. Now here the point is, among these aldehydes and ketones, which one will be more reactive towards nucleophilic addition reaction? If a nucleophile wants to come in and attack, where does it prefer to go? Whether it will go to the carbonyl carbon of aldehyde or carbonyl carbon of a ketone. Let's try to understand that. Now, in this, we can see in aldehydes, we can see one R group, which is nothing but electron donating group, which is our plus I group. Similarly, in ketones, we can see two alkyl groups, which are both of them are going to release electrons to the electrophilic carbon. So the carbon is going to satisfy in ketones up to maximum level, because here two friends are there to help, which means here the carbon will become less electrophilic actually, right? So उसके पास जो electron deficiency है, that will be satisfied by these two groups actually, these two friends. But in aldehydes we have only one R group which can help the carbon, electrophilic carbon, which means the positive charge will be more available at the aldehydes. Hope it is clear. So hence the nucleophilic attack takes place easily at the carbonyl of the aldehyde only, which means aldehydes are more reactive. Aldehydes are more reactive. Aldehydes are more reactive towards nucleophilic addition reactions. Very important point. So this point we are going to use in the reactions actually. So we are going to use this particular concept in intramolecular aldol condensation, where we have a ketone and aldehyde within the same compound. Then we are going to take the help of this particular concept. So at that time you have to remember this concept actually. So one thing for sure, sir, in aldehydes there is only one alkyl group which is going to help the electrophilic carbon, which means the electron deficiency is still more available at the electrophilic carbon in aldehydes, whereas in ketones that particular electron deficiency is compensated by two alkyl groups, which means the carbon of the ketone, the electrophilic carbon of the ketone will be less electron deficient in the case of ketones. So that's the reason if a nucleophile want to attack, that will prefer to go to an aldehyde electrophilic carbon. Clear? Hope it is clear. Thank you. So next, let me ask some questions here. So which of the following compounds does not undergo aldol condensation? Yeah, this is the question. Okay, yeah. So options I'm giving you is formaldehyde, is benzaldehyde, and you take trimethyl acetaldehyde, and then you take acetone. Come on, and you take acetaldehyde. Come on, you just try to tell the answer for this. Since acetaldehyde doesn't contain any alpha hydrogens, and even benzaldehyde is also the same situation. In benzaldehyde also we don't have any alpha carbon here. This doesn't undergo aldol condensation. Trimethyl acetaldehyde. Acetaldehyde is this, and then trimethyl is 3 methyls here. So this is our alpha carbon. This is our alpha carbon. There are no alpha hydrogens. So this also must be our answer. Whereas acetone and acetaldehyde. Acetone will have 3 alpha hydrogens. Acetaldehyde also have alpha hydrogens. So these two compounds will show aldol. So which means the first three does not show aldol condensation. Clear? Let's see another question. So which of the following compounds undergo aldol now? So in the previous one I asked does not undergo. So which compounds does not show aldol, and here which compounds will show aldol condensation. So the first option is benzophenone. So if you just know the structure, so this is benzophenone. So benzophenone में हमको alpha hydrogens नहीं होता है. So this compound will not show aldol. Whereas acetophenone, you know the structure of acetophenone. Acetophenone is this. Yes. And now if I'm not wrong, these are the alpha hydrogens. So we have alpha hydrogen, so obviously this will show aldol condensation. And the phenyl ethanol, what do you mean by phenyl ethanol structure, please? Phenyl ethanol, yes, this is phenyl ethanol. And again these are the alpha hydrogens. We have alpha hydrogen, this one also will show aldol condensation. Chloroacetaldehyde का structure क्या है? This is acetaldehyde. This is our acetaldehyde. Chloroacetaldehyde is nothing but this one. So one of the hydrogen will replace by chlorine. Still we can see the alpha hydrogens. So obviously we can have this also into the answer. So all B, C, D will show aldol condensation. Hope you understood. So next we will move into aldol condensation reaction and its mechanism. So let's move into the reaction aldol condensation. So one must know the definition for aldol condensation. If we can understand the definition, then it will be easier for us to understand or to attempt any kind of competitive exam questions. Okay. So here we need to take carbonyl compounds. So mostly we are going to take either aldehyde or a ketone, which must contain alpha hydrogen. Yeah, this is very important. So the aldehyde or ketone, whatever we are going to take, that must contain alpha hydrogen. So undergoes condensation, with a base, or we call it as an alkali also, to form what it is going to give us. It is going to give us a beta hydroxy carbonyl compound. Beta hydroxy carbonyl compound. Yeah. And that beta hydroxy carbonyl compound, we are going to call it as aldol. This is nothing but our aldol. And that aldol, whatever beta hydroxy aldehyde or whatever ketone we have got, that upon strong heating gives alpha gamma beta unsaturated carbonyl compound by losing water. Yes. So this is nothing but our aldol condensation. So let us try to understand the definition once again. So carbonyl compounds containing alpha hydrogens undergoes condensation with a base to form a beta hydroxy carbonyl compound, which is nothing but our aldehyde, and that upon strong heating gives alpha comma beta unsaturated carbonyl compound. Let us take one example. So here one must remember the condition, that is the aldehyde or ketone we are taking must contain alpha hydrogen. Yeah. So let us take the example of acetaldehyde. Yeah, we know that acetaldehyde contains 3 alpha hydrogens actually. Yeah, the condition is satisfied here. So we are supposed to take 2 moles. 2 moles. So whatever aldehyde we are going to take or whatever ketone we are going to take, that must be taken 2 moles. Two similar aldehydes or two similar ketones we need to take. So whatever the substrate they have given, we are supposed to take them 2 moles. Okay, so once if starts reacting with a base, that is strong base, we can take NaOH or KOH, or we can also take barium hydroxide, or we can even take the salts of the strong bases and weak acids, which is nothing but our K2CO3, potassium carbonate. So what we are going to get in the first step? Beta hydroxy carbonyl compound, right? So yeah, if you look at this, don't worry, I'll discuss, or I'll go for the mechanism also. So this is nothing but our beta hydroxy carbonyl compound. Why? So this is our carbonyl functional group, and then this is the directly attached carbon alpha, and the next adjacent one is beta. So beta पे हमको क्या कौन सा ग्रुप दिखाई दे रहा है? OH. So beta hydroxy carbonyl compound. So this is actually called as 3-hydroxybutanol or beta hydroxybutanol. So this upon further strong heating. So what it is going to undergo? This is going to undergo, I am writing this hydrogen like this. Okay, one of the hydrogen I'm writing here. And now ये जो water molecule is there, that is going to eliminate as H2O, and then we are going to get a double bond here. So if you observe carefully, the product will become this. Come on, check it. CHO. So if you look at this, this is the alpha carbon and the adjacent one is beta. So in between alpha and beta we have a double bond, so we can call it as alpha comma beta unsaturated carbonyl compound, right? Hope you understood. And the compound name is crotonaldehyde actually. Okay, so I'm just writing the reaction here once again, please check it once again. So if we take acetaldehyde here, 2 moles. So in the first step, in the presence of a base, we are going to see a beta hydroxy carbonyl compound, OH, and then CH2 and then CHO. Okay, and then this upon heating it is going to lose water molecule to give alpha comma beta unsaturated aldehyde. Yes, if you look at this, the compound name is actually crotonaldehyde. This compound name is crotonaldehyde. So very important compound. So the common name for this compound is crotonaldehyde. The IUPAC name will become but2-ene-1-ul. Okay, so it is but2-ene-1-ul. Very important. Okay, acetaldehyde. Acetaldehyde. So in the first step, we will be reacting with a base, and the second step we are heating it. We will get a compound X. And what type of isomerism is shown by the compound X? So just now we have seen the compound X is nothing but our crotonaldehyde. Yes, I hope it is clear. And if you observe carefully in that particular compound, that alpha comma beta position pair, we have hydrogens, right? Yes. So these are the hydrogens with one of the methyl here, another one is CHO. If we just interchange the groups at the double bonded carbons, you just check, we will be getting geometrical isomers if I'm not wrong. So these two are geometrical isomers. So this is the trans form and this is the cis form. Very important. So the compound X given in the question will show geometrical isomerism. That must be the answer actually. Hope it is clear. Okay, let us go for the mechanism. How our acetaldehyde is becoming crotonaldehyde. Let us go for that. Okay, so let us go for the mechanism once. So mechanism involves two steps actually. So the mechanism in aldol condensation involves two steps. What's the first step? Formation. Formation of enolate ion. Formation of enolate ion. So what exactly is enolate ion? Let's see this. So if we just look at, I'll write one of the hydrogen like this for our convenience. Okay. Now this OH minus, since it is a base, it abstracts a proton. And which proton is ready to go actually here? This alpha hydrogen only. Yes. Why it goes out actually? That hydrogen, if it goes out, then we are going to get some kind of chemical species like this. And this carbon gets a negative. And this negative is resonance stabilized, if I'm not wrong. So this negative charge is resonance stabilized, which means this hydrogen will prefer to go out. Hence, that particular hydrogen is considered as acidic hydrogen. So this particular ion is called as enolate ion. And if you look at, the carbon is having a negative charge on that. So which means it's an example of carbene ion. Carbene ion. Yeah. So very important, students. This is very important reaction. Hope you understood what is enolate and what is carbene ion. Okay, and now, so once the enolate ion is formed, in the second step, what happens is nucleophilic addition reaction takes place. Nucleophilic addition reaction takes place. Now, who is our nucleophile? It's nothing but our enolate ion itself. Enolate ion itself, it behaves as a nucleophile now. So the enolate ion formed from one of the acetaldehyde molecule will now attack the another mole of the acetaldehyde. So where does that enolate ion prefer to go now? We know very well. This is the electrophilic carbon we have discussed earlier. So this particular nucleophile will go, and then what we are going to get, that is CH3 CH, and then we are going to get O minus, and then the CH2 and then CHO. Hope it is clear. And in the first step, the acidic proton combined with the OH minus ion of the base and left as water, and that hydrogen ion from that water will again now come and attack on the negatively charged oxygen to give the beta hydroxy carbonyl compound we were talking about earlier. So this is our aldol, right? Hope it is clear. Now, in the last step, we will see the elimination of water, elimination of water, okay, from aldol, yes, gives, what it will give us actually, alpha comma beta unsaturated aldehyde only or ketone, right? Yes, let us take that here, that is CH3, CH, OH, and again we have CH. Let's see this. Yes, hope it is clear. And now, when we are heating this, we see what a molecule eliminates. How does it happens? Always take out hydrogen from alpha carbon only, so that we are going to get crotonaldehyde. Clear to everyone? Hope it is clear. Those who are watching. So this is our crotonaldehyde. Very important, students. Yeah, this is our crotonaldehyde. Okay, so this is actually the mechanism part, but leaving the mechanism, we can even write the reaction in an easier way actually. So without all these mechanism and all, yes, we need to understand the mechanism, but in exam hall, so to write all these steps, it will take some time. So just what we can do is, since we are taking 2 moles of acetaldehyde, one of the mole of acetaldehyde or whatever aldehyde or ketone we are taking is used for the formation of enolate ion. The other mole is used to attack the nucleophile to the electrophilic carbon. So let us do this reaction within single step. Okay, so within single step, how to identify the direct final product. So let's see that. Okay, what happens in this is, let us take one of the acetaldehyde molecule like this and other acetaldehyde molecule pointing the acidic hydrogens towards the oxygens to make the things easier for us. So what happens is, when we are doing this reaction, that is, okay, so in the first step we are reacting it with the base, and in the second step we are just heating it. Okay, yes, and then what happens here is, this water molecule to be eliminated and attach the two groups actually. That's it, that gives our final product. Yes, if I'm not wrong, please observe carefully and check it. Yes, so we have skipped all the steps, all the mechanism steps. Directly we have got the final product. Hope it is clear. Similarly, now let us try to understand. Let us try to understand by taking 2 moles of propanol. 2 moles of propanol. So 2 moles of propanol. So in the questions, don't expect this number to be okay given actually. Okay, so they won't give that coefficient. So just by looking at the reaction conditions, we have to know that is aldol condensation, and we are supposed to take 2 moles. That's it. So here, what is the major product? Come on, let us try to. So please, if you go with respect to the mechanism and all, it will take a lot of time. So just let us take our shortcut method, that is CH3 and then CH2, and then let us write down this one of the group like this. And I told you, please point out the acidic hydrogens towards the oxygen, please. Okay, yeah, these are our alpha hydrogens, so acidic hydrogens. So those hydrogens need to be removed along with the oxygen as water. And now come on, there is nothing wrong in this. Come on, try to write down the product. CH3, CH2, and then CH double bond C, and there is a CH3. Yes, this must be the major product for this reaction. What's the name for this? It's 2-methyl pentuene 1-ul. Hope it is clear. It's 2-methyl pent 2 in 1-ul. And if you look at this, yeah, again this is the alpha carbon, this is the beta carbon. Okay. With respect to the aldol, these are the alpha comma beta unsaturated aldehydes. Hope it is clear. Okay. So let us take one more example. You take acetone. Acetone, and then try to react it with a strong base, followed by the heating. Yes. And now, what's the product? Come on, everyone, try to do it. I'll just pause the video. Come on, you try to do it. You try to identify the product. Later, I'll give the product structure, and then you please try to correlate. And then we will understand how much you have gained from our class. Chalo. Okay, I'm doing this. So simply, come on, I'm keeping one of the oxygen like this and pointing the alpha hydrogens towards the oxygen, and then yeah, this is nothing but our acetone. And yeah, simply we have to take out water. So what we are going to get? Yes, yeah, this is nothing but this compound is called as methyl oxide, methyl oxide. What's that? Methyl oxide. The IUPAC name, you can write it. What's the IUPAC name for that? A functional group must get the least number 1, 2, 3, 4, 5. So 4 methyl pent 3 ene 2 on is the IUPAC name of methyl oxide. So so sometimes they even give this. So 3 moles of acetone undergoes this aldol reaction, but here we have to take some vigorous condition, that is HCl. So HCl, and then what happens? The reaction will go in the same way. Just what we are supposed to do is, sir, yes, point out the acetic hydrogens like this. Yes, hope you understood. Again, we have another side also, 2 more acetic hydrogens are available. So this is one of the mole, and then we have another acetone molecule. Yes, hope you understood what I'm doing. So this side one H2O will lose, another side one H2O will lose. So finally we are going to get, after the heating step, what we are going to get is, yeah, a conjugated ketone we will get. Yes. This compound is called as phorone. Yes. Phorone. What is the IUPAC name of this again now? So 1, 2, 3, 4, 5, 6, 7. So from either side, the functional group is getting 4 only. That's a good thing here. So you can now call it as 2, 6 dimethyl hept 2, 5 diene 4 on. Hope it is clear. You please try to write down the IUPAC name. Okay. Yeah, this is what happens in our aldol condensation. Let's see another question. You take acetophenone, and then come on, aldol condensation followed by heating. Yes, what's the product? Come on, you try to identify that. So again, just simply what you have to do, one side benzene, another side we have a methyl with a double bond O. So we have alpha hydrogens on the methyl, and then we have what happens here, this H2O need to be taken out, and then what we are going to get is, okay, let me write benzene. So we have a benzene ring attached to the carbon, a double bond, and there is a methyl.
with a CH, C double bond O with a benzene ring. Hope it is clear. So this is the product we will get. What's the IUPAC name for this? It's 1,3 diphenyl butene 1-one. It's very important. So this is our parent chain. So these are the phenyls. So functional group should be given in list number 1, 2, 3, 4. 1,3 diphenyl butene 1-one. It's very important. Right? Yeah, very good. Let's move to the next one. You take phenyl ethanol. Take phenyl ethanol. Take phenyl ethanol. Again, OH and then heating. Come on. What's the product? Try to do it fast. So let us try to write down this according to our easier way. CH2, CHO, and then this is our alpha carbon, right? So we have to point out the hydrogens towards the oxygen, and then we have a phenyl, and then we have a CHO. Simply we have to take out water, and then what we are going to get? We are going to get a benzene, and then CH2, CH double bond, and then there is a carbon with the phenyl ring, and then with the CHO. Yes, this is the major product, right? Superb. Next, another one. Let us take lactones. We'll take a cyclic ester. We'll take a cyclic ester. Come on, come on. We'll take a cyclic ester. We'll take a cyclic ester and then perform. Yes, come on. You try to do it. Same, nothing different here. Come on, you try to write down. So, and then now, next alpha hydrogens need to be pointed out towards the oxygen. Okay, yes, these are the hydrogens only, right? Yeah, simply, come on, take out that. So this is what the product is, very important. Suppose, let's say we have cyclohexanone, and now again we are going with two steps. Yes. Suppose, let's say we are getting a product X, and how many pi electrons are present in the compound X? This is the question asked previously in JEE. So product में कितना pi electrons होता है? Nothing you have to do. Come on, point out one oxygen and please acidic hydrogens towards the oxygen. Acidic hydrogens. So we have two acidic hydrogens, if I am not wrong. Yes. And now what happens? There is a water molecule need to be eliminated. And then what happens here? That is, two cyclohexanone rings are going to be attached with each other through a common double bond adjacent to a carbonyl group. So this is our product X. Now what's the answer for the question? How many pi electrons are available? 4 pi electrons. If I'm not wrong, 4 pi electrons are available. Yes? Nice question. This is the question given in IIT, previous JEE. So the same question I have taken here. So pi electrons are 4 actually. Pi electrons are 4. Please update here. So pi electrons are 4. Next we will move to the other question. And this is a kind of intramolecular aldol condensation. Intramolecular aldol condensation. So what do you mean by intramolecular aldol condensation actually? Generally what we do, we will take 2 moles of such aldehyde or ketone for the aldol condensation. But within the same compound or within the same molecule, if we have both the carbonyl groups available to undergo aldol condensation, then that particular reaction is called as intramolecular aldol condensation. Where, or let us try to understand. I'm writing the compound again here. Please, you try to understand. So there is one ketone group here, and there is one aldehyde group here. Yes, there is one aldehyde group here. Very important. So now, what happens here is, in the previous cases, we have taken two such moles of either aldehydes or ketones. But here, no need to take that because both the carbonyl groups are available within the same compound. Okay, so now just what we are supposed to do is the same thing. So the reaction will go in same way. Either we will get enolate ion here, and that will go and attack on this electrophilic carbon, or we will get a enolate ion here, and that will go and attack this particular carbonyl carbon. Which is more favorable? That we need to understand here. That we need to understand. That is we need to understand. Here we have seen that among aldehydes and ketones, aldehydes are more reactive towards nucleophilic addition reactions, right? So which means always the enolate ion with respect to ketone will be formed, and that will be going and attacking the electrophilic carbon of the aldehyde. Yes, beautiful. So that happens in intramolecular aldol condensation. Always the enolate ion with respect to the ketone will go and attack the electrophilic carbon of the aldehyde. And there we need to be a bit careful with the size of the ring. Size of the ring is also matters, because suppose let's say here we have acidic hydrogens, and from that if we take out a hydrogen, we will get an enolate ion there, and that particular enolate ion will go and attack this particular electrophilic carbon. How many membered ring we are going to get? Check it. How many membered ring we are going to get? So we are going to get of 1, 2, 3, 4, 5, 6, 7 membered ring we are going to get. So that is not good actually. We know 7 membered ring is less stable than 6 membered ring. And here 6 membered ring is not possible. If this particular enolate ion, is going to attack the electrophilic carbon of the aldehyde, we are going to get a 7 membered ring. So that must not take place here. So what we are going to see is the enolate ion with respect to this alpha carbon is going to attack now. I hope you understood the reason. If the previous enolate ion attacks the carbon, then we will be getting a 7 membered ring which is not stable according to Bayer-Strain theory. So we are supposed to go with 5 membered ring only. So this particular enolate ion will attack, and now this will come out. We will get a ring structure. So let us try to draw the same compound according to our convenience. Okay. So this is the same compound I have drawn here. So now let us go with this particular enolate I am talking about. So what we are supposed to do? Just we are supposed to take out water and just attach these groups and take a double bond. Yes. So this hydrogen I'm just taking out. Okay. This hydrogen I'm taking out, and this bond will be no more. So this is our product. This is our product. You check just where this structure is actually. So if you look at the fourth option is the most suitable one for this. Hope it is clear. Let's move into the next question. Yes. Again we can see here X and Y. They are asking even aldol also. So we must go through the mechanism only, because they are asking both. They have taken cyclopentanone. Okay. Yes. Cyclopentanone is there, and it is reacting with another cyclopentanone, The first step, in the presence of a base, we know that this one of the cyclopentanone gives enolate ion, and that enolate ion will attack the another one to give, yes, let's draw the structure together. You also try from your side. So this will become O minus, and later that will be attacked by hydrogen. We have seen already. Yes. Yeah. This is our aldol here. Please check where this structure is actually. Please check where is our structure. Okay. Yes. And then next, this upon heating, we need to eliminate the hydrogen from the next alpha. So this water goes out to give, yes, there is a common double bond among the two rings actually. Yes, please check, this is the Y. Come on, where is the structure? Come on, check it. If you look at the perfect answer for this is the third one. Yes, the third option is the right answer. If you please concentrate, this is given in 2021 JEE. Okay. Yes, I'm moving to the next one now. I'm moving to the next one. Again, this is a kind of what? What type of reaction it is? Did you identify? This is intramolecular aldol. Come on, intramolecular aldol condensation only. Hope you identified it. Because why it is intramolecular aldol? Because both the required carbonyl groups are present within the same compound. Again, this has to be taken through two steps. Okay. So again they are asking both. Again they are asking both what? X and Y, which means aldol and also the final heating product in the last step. So yes, now we have seen, sir, with respect to this ketone, there are no alpha hydrogens here. We must involve this alpha hydrogen, this enolate ion only here. Come on, how many membered ring we are getting? So it is 1, 2, 3, 4, 5, 6 membered ring. So we are getting a 6 membered ring. How many membered ring we are getting? 6 membered ring we are getting. Please check it once. 1, 2, 3, 4, 5, 6. But in the first two options, we have 4 membered ring. Wrong answer. Eliminate them. Eliminate them. Just directly eliminate. Okay. Okay. Next. Sir, 6 membered ring we are getting. I'm writing directly. I hope you can understand. I'm writing directly a 6 membered ring. 6 membered ring directly. I have written directly. Now we have a ketone. This ketone, I have taken ketone here. And now ketone के adjacent carbon पे we have two methyl groups. And then next later we have two carbons left as it is. And for the last carbon we have what? OH. Yes. This must be the X compound where we have that. Where we have that. Please check it. Please check it. Yes. So in 3 and 4, both the options have given the same one. So we must go to the next one. So next we must eliminate the hydrogen from the alpha. Yes. So now I hope you understood what to do and what must be the final product. So there is a ketone and there are two methyls, and now we are having a double bond next adjacent to the ketone. Obviously our answer is the fourth one. Yeah, beautiful, beautiful. See, check the importance of the beauty of the aldol reaction. Beautiful, right? Come on. Yes. And then the last one I have here is, it's an easy one. It's an easy one. Come on, you try to solve from your side. Come on, come on, come on, come on, you try to solve it from your side. So again we have a aldehyde and we have a ketone. Come on. Beautiful. Now I told you, and I hope you are pretty much confident. Sir, here there are two possibilities of getting enolate ions. We must go with these enolate ions only. We should not take the enolate ion with respect to the aldehyde, because aldehyde need to be attacked by the enolate ion of the ketone. So among these, which one is a good one actually? Come on. So if you take the last one and attack here, it's how many member ring we are getting? 1, 2, 3, 4, 5, 6, 7 again. So this is eliminated. No, no, no. We should not go with that. We should not go with that. So ultimately, our hint, yes, this must be the attacking enolate. Superb, superb, superb. Now let us try to write. So 5 member ring. So option 4 is eliminated directly. Now we are supposed to get this. Come on, please. So this is our enolate carbon, and then later we have 3 hydrogens. And now come on, what we are supposed to do? Come on. I hope you understood. Come, that's it, that's it, that's it. Check it, check it. Where we have that? Where we have that? Come on. So it must be the first answer. Come on. Such a beautiful reaction, aldol condensation, and I have included intramolecular aldol condensation also in this video. Hope you understood each and everything. Hope you liked it. Please, from now, you are going to get continuous videos on each and every name reaction of organic and also with other concepts, physical, inorganic, organic. You are going to get regular videos. I'm so sorry. When I saw your comments for my previous videos asking me why did you stop uploading the videos. So please upload. We have IIT-JEE exam in the coming January or maybe April. So I really heartfelt for that. So I'm so sorry for not updating or not uploading regularly, but from now you are going to get it regularly. Yes, I'm sure, I'm promising. Please, 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 please. I'm requesting. Don't unfollow. Please follow the channel. Please follow the channel. Please press the bell icon so that you get the update as soon as I uploaded the video. Thank you so much for your patience. I hope you liked the video. I hope you enjoyed the video. Yes, so I want your continuous support. Please spread my channel to your friend students also. Please. Thank you so much. Signing off with aldol condensation. See you.